Kia ora Year 11 and anyone from Year 12 who's redoing AS. Arthur sent me in this request for another Volumes of Solids question, and it's a really good one that will reinforce the one that I did the other day. So someone, I think it might have been Zachary, requested one from 2020, and this is the link down here, right? So if there's a May 2020 Volumes of Solids problem, and it's similar to this one in that we've got two functions. And we're finding the volume when the shaded region gets rotated around the axis. Okay, so I'm going to go quickly through this one much faster than I did in the last video, but the basic idea is that we're going to think about rotating all of this first around the axis, and we're going to get some kind of vase, right? And then we're going to take out of it what we get from rotating this area around the axis. We're going to do two separate volumes, and we're going to find the difference between those volumes. So in general, the way that I find a volume by rotating something is that I'm using the disk method, where I'm thinking about adding up a whole lot of tiny slices of whatever pottery thing that I'm working with. So the first one here, V1, is going to come from integrating that straight line. Oh, that's a terrible picture there. So the first thing I need to do is to work out what y is, and y here is equal to 5 minus x. So the radius here is given by that y function, and the volume is given by pi times the integral between 4 and 1 of that radius squared, right? So what I have to do is to take that 5 minus x and square it. And then v2 is going to come from doing the other one, and in that one we've already got y as the subject. So we're going to take this 4 over x and we're going to square that. So v2 will be equal to pi times the integral between 4 and 1 of 4 over x squared. Now notice that I've pulled that pi through the integral sign just to make the working slightly cleaner. Okay, so probably some of you are going to hang up the video at this point, but I'm going to keep on going. I'm being accompanied here by a dog that is getting slightly sketchy, so we'll see how this goes. I might have to go very quickly near the end. We've got 25 minus 10x plus x squared, so nice easy integral. And that gives me this. So pi times the integral of 25x minus 5x squared plus 1/3 x cubed at those limits. Now be careful with this. You haven't got 0 here, and this is not going to become anything trivial at the bottom limit. So we've got to substitute both in, right? So the top limit we get 25 times 4, so 100 minus 5/16, 80, plus 1/3 of 64. And then the bottom limit will be 25 minus 5 plus 1/3. So cleaning all of that up, we get pi times 20 plus 64 over 3 minus 20 minus 1/3, which is quite nice because I end up with pi times 63 over 3, which is a nice round 21 pi, and I'm going to leave it in that form. So that's my V1. Now we go and do the same thing for V2. So V2 is going to be the integral of pi times, so it'll be 16x to the negative 2 dx, which gives me pi times negative 16x to the negative 1. Evaluating that gives me pi times, sorry about the very loud dog drinking water noises. I'm sure you can hear that down the video. I guess it could be worse, right? Minus 16 over 1. So you'll see this negative number, but this is a positive number because I've just remembered to put my negative sign back in. So we've got pi times negative 4 plus 16, which gives me 12 pi. So my total volume is what I get from this big weird thing that I've rotated minus the scoopy thing that I've rotated. So V1 minus V2 is equal to 21 pi minus 12 pi, which is 9 pi. All right, hopefully you can see that these volumes of solids things are not that bad once you get into them, but you do have to remember to do the two separate volumes, not to try and combine the two functions, right? And I went through, hopefully, a little bit for you in that last video why that's the case.